problem that I actually wanted to do because it relates to the challenge that we're going to be doing with the toilet paper later on next week or later on this week. And I want to get you set up, but I'm going to actually have you finish the problem on your own because I want to kind of keep the video short. So here's the idea. We're going to have a yo-yo, and it's got a rotational inertia that I'll call I, and it's got a mass m. It has a radius r, and it has a string with length L. And so we want to know a bunch of different things about the yo-yo, including its acceleration, its time to reach the end of the string, its linear speed at the end of the string, and its translational kinetic energy, and its rotational kinetic energy. And finally, we want to know its angular speed. So to get all these things taken care of, let's actually go ahead and get this set up. So we draw an extended free body diagram where we have the tension and we have the weight on the mass. And we go ahead and we set up our equations. So the tension times the radius, because it acts perpendicular, is going to equal I times alpha. And then we have the weight dragging the object down, and the weight is going to actually end up equaling well, actually, we've got to be careful because it's not just the weight that's dragging the object down. I have to follow my own recipe here and actually look at the free body diagram. So I have the weight pulling on the mass downwards. It opposes tension, and the effect is that my mass now accelerates. So these are kind of the two formulas that we need to go ahead and get started on this problem. So I would start with these. And then the recommendation is don't forget that alpha equals A over R. And don't forget that translational kinetic energy, that's going to be 1/2 mv squared. And the rotational kinetic energy is going to be 1/2 I times omega squared. And of course, omega is V over R. So that's a good way to get started on this problem. So this is kind of the homework problem. And good luck getting started on it, and I hope you get the answers submitted. And this is really a good test of, I'm hoping this problem's easy. If it's not, come by, get a little bit of help, because this is about what we should be able to handle at this point without problems. That doesn't mean you're a bad person if you can't. It just means you need to get a little bit of extra help, and I'm here after school every day to help you.